All right, so this video is going to be the part 2 packet of the work and energy. So we're going to do pages 25 through 27 on this video. Okay, so we're going to start talking about potential energy. So potential energy is energy stored in an object. Okay, so gravitational potential energy is just the energy stored in an object as a result of the object's position relative to 0 point. Okay, so your 0 point usually means the ground. Okay, so where you are relative to the ground. So like basically if you have height, you've got more potential energy because you're further away from the ground, which we'll get to in just a second. Work has to be done by a force to lift an object to a certain height. So there's your key word there for potential energy. Okay, work stores the energy as gravitational potential energy. So remember we said work equals force times distance. Now when we're lifting something, that force becomes mass times gravity times distance. Okay, well in this case, we're actually talking about going up. So it's basically instead of saying distance, we're going to say work equals mass times gravity times height. Now, we know energy is equal to work. So in this case, we can replace the work with potential energy. So potential energy of gravity equals mass times gravity times height. So it's got three factors. You got mass. Okay, so the bigger you are, the more energy you're going to have. Gravity, which is going to remain constant. Okay, and then height. The higher you are, the more energy you're going to have. So think about when I like to think about this, we'll do a lot of examples here in a little bit, is roller coasters. It's a mixture between potential and kinetic energy. You have height, more height at some points, and then you have more velocity at some points, more kinetic energy at some points, and how they kind of shift, which we'll get into a little bit later. So we'll kind of keep it simple for now. We have a 50 kilogram girl, so our mass is 50 kilograms. Climbs a 3-meter high staircase, so my height is 3 meters. What is the gravitational potential energy at the top of the stairs? So that means I am looking for potential gravitational energy. So we know our equation now, so remember PE equals mgh. So my mass would be 50, gravity is 9.8, and then height would be 3 meters. Okay, so multiply that all out, and so my total potential energy would be 1,470 joules. So that is how much energy she has built up to when she gets at the top of the staircase. So example 2, an 800 kilogram car, so mass is 800 kilograms, goes up a 40-meter high hill, so my height is 40 meters, then down a 100-meter hill. Okay, so we're actually going to go down 100, so this is actually going to help if we draw this out, because then you got two different heights going on. So I want to know what is the change in potential energy, so that's what we're looking for is PE. So I'm going to kind of draw this out. So I have a car going along, and it's going to go up a 40-meter high hill, and then go down a 100-meter high hill. So I'm going to end up lower than where I started. Okay, so this will be your start point. Okay, so my starting point, we're just going to pretend that ground continues to there. I went up 40 meters and then down 100. So that means the distance from where I started and the bottom of the ground is going to be 60. Because I know my entire distance going down was 100 meters. Okay, so we finished down here at the bottom. So I basically want to figure out how much potential energy did I lose from where I started and where I ended. Okay, so my change of potential energy, okay, basically equals my mass times gravity times my change in whatever height is. So my mass is 800. My gravity is still 9.8. And my height is, I started here, that's basically like my 0, and I went down 60 meters. Okay, all I care about is what was my energy compared to where I started to where I ended. I'm not looking at where I was up here at the top of the hill, okay, because ultimately it's where you end versus where you start. Okay, so all I care about is where I started and where I ended. So my change in height would be a negative 60 since I'm 60 meters below where I started. So that comes out to be negative 470,400 joules. Okay, so again, it ended lower than where you started, so it's okay to be negative because you lost energy, because you no longer have that height to your advantage. Okay, so let's move on to the next page. Now this is just going to be a potential and kinetic recap. This is a mixture of both. Kinetic we've already done, so some of this should be pretty simple. You serve a volleyball with a mass of 2.1 kilograms, so I got mass. Leaves your hand with 30 meters per second, so I have velocity. So this ball has blank energy. So if I have mass and velocity, I am dealing with kinetic. Okay, so remember, kinetic energy equals 1/2 mv squared. So I'm going to plug that in. So 1/2, my mass, which is 2.1, my velocity is 30, and that is squared. So multiply that all out, and I get 945 joules. 2, a 10 kilogram mass is lifted. So I got to worry about that, lifted, so that means gravity's a factor. And I gave you height. Okay, what is its blank energy? So if I'm dealing with mass and height, this is going to be potential energy. Okay, so I need to calculate it. So remember, PE equals mgh. So my mass is going to be 10 kilograms. My gravity is 9.8, and my height is 2 meters. So multiply that all out, and you get 196 joules. Number 3, there's a ball at the top of a tower that is 45 meters high, so I gave you your height. The ball weighs 190 newtons. So when I give you weight in newtons, that is basically just telling you what mass times gravity already was. Okay, so if you wanted to find the mass, you could. You just divide 190 by that 9.8, and you could figure out what the mass is. But if I give it to you in newtons, it's basically just doing that math for you. Okay, so if I'm dealing with mass and height, this is going to be potential energy again. So potential energy equals mass times gravity, which I already know is 190, times my height, which is 45. So that comes out to be 8,550 joules. Number 4, the potential energy of an apple is 6.0 joules, so I just gave you PE. The apple is 3 meters high, so I gave you your height. What is the mass of the apple? So that means I'm looking for M. Okay, so now we can plug in. So PE is actually 6.0. We know what it is. Mass, I don't know. I'm leave it as M. Gravity is 9.8. And height is 3. So basically, I just got to get M by itself. So divide both sides by whatever 9.8 times 3 is. And I get a mass of 0.20 kilograms. What is the velocity of a 500 kilogram elevator that has 4,000 joules of energy? So I'm looking for velocity. I have a mass. And I have energy. Now, that could be potential. That could be kinetic. Okay, but since I'm actually looking for velocity, this is going to be kinetic energy. So 4,000 equals 1/2 my mass, which is 500, times v squared. Okay, so divide both sides by whatever 1/2 times 500 is, and then square root both sides, and you get a velocity of 4 meters per second. I'm sorry, just a little off there. 4 meters per second. 6, what is the mass of an object that creates 33,750 joules of energy by traveling 30 meters per second? So I'm looking for a mass. I gave you energy, and I gave you a velocity, so that means we're going to be dealing with kinetic energy. So we're going to do the same thing. Now we're just looking for mass. So I have 33,750 joules equals 1/2 my mass. I don't know. I'm leave it as M, and my velocity is 30 squared. So get M by itself, and I get a mass of 75 kilograms. Okay, moving on to the next page. This will be the last page for this video. At what height is an object that has a mass of 50 kilograms if its gravitational potential energy is 9,800 joules? Okay, so I'm looking for height. I give you mass, and I give you potential energy. Okay, so potential energy is 9,800 equals my mass, which is 50. Gravity is 9.8. And height, I don't know. I'm going to leave it as height. So solve for H. And I get a height of 20 meters. Number 8, what is the potential energy of a 3-kilogram ball that is on the ground? So remember we talked about potential energy equals mass times gravity times height. Well, if my height is 0, meaning I'm on the ground, that means everything's 0. So that means my potential energy is going to be 0 joules. So if you are not even off the ground and you have no height, then you have no potential energy. Number 9, a roller coaster is at the top of a 72-meter high hill. So I have height and weighs 966 newtons. So I just basically gave you mass times gravity right there. At the top of the hill, the coaster has potential energy. Since we're doing mass, gravity, and height, okay, so I'm going to find my PE. I don't know what it is. So PE equals mass times gravity, which is 966, times my height, which is 72. And we get 552 joules. 10, what is the kinetic energy of a 3-kilogram ball that is rolling 2 meters per second? So I'm looking for KE. I gave you mass, and I gave you velocity. So KE equals 1/2 my mass, which is 3 kilograms, times my velocity squared, so 2 squared. So it's going to be intense math. Comes out to be 6 joules. 11, a baby carriage is rolling down the hill at 18 meters per second, so I gave you velocity. If the carriage has 90 joules of kinetic energy, so I just gave you KE. What is the mass? So you're looking for M. So KE is going to be 90 equals 1/2 mass. I don't know. I'm leaving it as M. And then my velocity is 18 squared. So get M by itself, divide both sides by 1/2 times 18 squared, and I get a mass of 0.56 kilograms. 12, calculate the kinetic energy of a truck that has a mass of 2,900 kilograms. So I'm looking for KE. I give you mass, and I give you a velocity again. So we're going to deal with kinetic energy. So KE equals 1/2 my mass, which is 2,900, times velocity squared, so 55 squared. So this is going to be a pretty big number. This comes out to be 4,386,250 joules. Okay, you got to think about is you have a really heavy truck that is moving pretty dang fast, so that is going to be a lot of energy. Now, this practice hopefully was good just for using KE and PE, okay, because you need to get real good at using kinetic energy and potential energy because the next page we go over is going to deal with both of them at the same time.